Hey guys, today's video is about model evaluation. We've discussed confusion matrix, accuracy, and error rates in the last video. Please make sure you understand those concepts before watching this one. Alright, today we are going to talk about class imbalance problem. As we said before, accuracy and error rates are not perfect measures, and they are often biased. The most serious problem happens when the classes are not balanced. By imbalanced class, we mean the classes are not evenly distributed in the data. In fact, the classes refer to the outcomes of the model prediction, like whether a person is going to buy a computer. The outcomes are yes and no. So, why is class imbalance a problem to the accuracy and error rate? Let's look at an example to figure it out. Say we have this summary table for a medical test. If you remember, the actual classes are the outcomes in the dataset. Therefore, when we want to know whether the classes are balanced, we compare the summation of a row. In this example, the class positive has 300 data points, negative has 5,150 data points. I hope it's obvious to you that the classes are imbalanced. To be more specific, the observations in class negative is more than 15 times larger than in class positive, so the distribution of classes is super imbalanced. In fact, this is not a special case. We often see medical tests that are more imbalanced than this one, like the diagnosis for rare disease. One other thing to note is that the actual classes is not always the row label. It might also be column label. In that case, we compare the column sum to determine whether the classes are balanced. Now you see how imbalanced classes look like. We can discuss how this situation makes the accuracy and error rate problematic. The accuracy for this medical test is 0.936. Just to recap, the accuracy is the percentage of correct classification among the dataset. So it's calculated as 100 plus 5,000 divided by the total number of data points. Intuitively, you might believe this model works fine or even wonderful because the model can classify 93.6% of data correctly. But is the model really that good? No, it isn't. If we only look at the class positive, we'll find the model classify 100 data points correctly, 200 data points incorrectly. In other words, out of 300 positive data, the model predicts 200 as negative. You might think, yeah, the model doesn't work well for positive data, but for negative data, it works excellent, and overall, the accuracy 93.6 seems reasonable. However, in a medical test, we only care about class positive. In specific, you would care about people who have the disease, not the healthy people, because most people are healthy. You might argue medical test is a special case, but it's not. Most of the time, there is a more important class among the imbalanced dataset. For example, for a product assessment, we want to find the defective products, and hopefully, that's the minority. And there are many other cases where we only care about positive class, so we need some measures better than accuracy. In fact, despite of failing to represent the performance of model on positive class, there is another problem of accuracy or error rate in imbalanced datasets. The problem is, you can almost always make accuracy higher by predicting all the data as the majority class. In this case, the majority class is negative because most people are healthy. So we try to predict all the people as negative and compare the accuracy with the original model. Here are the accuracies for two scenarios. The original model has accuracy 0.936. The new model has accuracy 0.945. Before we continue, I want to remind you the error rate is just 1 minus the accuracy. The two concepts are complementary, so when we discuss the problem of accuracy, the error rate actually has the same problem. Alright, so as you can see, the new model has higher accuracy. But what does this mean? This means the accuracy is not a good measure because the new model is totally useless. To illustrate, this is a medical test, but our model predicts all people as healthy. So if you go to a hospital, the doctor always tells you are healthy. Would you think this is a good doctor? I guess not, right? However, the accuracy tells us this is a good model. Now you see sometimes accuracy and error rate can be biased. So we need other measures to evaluate the model, and we will introduce them in the following videos. Okay, this is the basic idea of class imbalance problem. Thank you for watching my video and see you next time.